Hello physics class, it's Mr. Ng and I wanted to make you a short little video about average velocity. So here, this is the sample problem from the book from page 44. It says, during a race on ground level, Andra runs an average velocity of 6.02 meters per second to the east. What is Andra's displacement after 137 seconds? So first things first, we got to know the formula for average velocity. Average velocity, this is the symbol for it, is equal to displacement, the change in displacement, right? This is how far it traveled, over the change in time, okay? And just to make it a little bit easier on you, I'm going to put this over 1. That way we could do some simple math that you might be used to. So all we got to do is kind of plug in. So we got V, D, T, right? Our V is 6.02 meters per second. Our D is what we don't know. And our T is 137 seconds. So let's just plug in. So now I got 6.02 meters per second over 1 is equal to our displacement, which is our I don't know. So I'm just going to do a question mark there, over our delta T, which is 137 seconds. So looks like all I got to do is cross multiply. So if I just kind of did some cross multiplying here, instead of a question mark, let's do an X, right? That's a notation that you're used to. That means X is equal to 6.02 meters per second times 137 seconds. Notice how seconds will now cancel out. So our X, or our displacement, is going to be equal to 6.02 times 137, and I get 824.74 meters. Just so you know, it looks like the problem is only giving us 3 digits to work with, so we can't use all 5 digits. We need to round it up to 828 meters. That is our answer. Okay, here's problem number 1 from your homework set. Problem number 1 says Heather and Matthew walk with an average velocity of 0.98. This is our average velocity eastward. If it takes them 34 minutes to walk to the store, what is their displacement? 34 minutes. So it kind of sucks because this is in seconds and this is in minutes. So I think the first thing we got to do is convert to seconds. But first things first, let's remind ourselves of the formula. Average velocity is equal to displacement over change in time, right? And we got our V, D, and T. So our V is 0.98 meters a second. Our D is our I don't know. And our T is 34 minutes. So we can convert 34 minutes to seconds, right? I'm going to do a fancy fraction called a dimensional analysis. So for every 1 minute, I got 60 seconds, right? And notice that minutes cancel out. So really, 34 minutes is actually 2040 seconds, right? So here, 2040 seconds. Fine. So now all we got to do is plug in. So I got 0.98 meters per second over 1 is equal to our delta D over our seconds, 2040 seconds. So again, it's just going to be a thing where we cross multiply. So I'm going to multiply this by 0.98, and I got 1999.2 seconds. Let's check out our sig figs. It's 2 digits, so we got to bring it down to 2 digits. So that means our displacement is equal to 2, 0, 0, 0. If I don't put a little decimal there, it makes it basically a 1 sig fig, which is going to be appropriate. That's the best we can do here. Good? Okay. Thanks for watching and good luck on your homework set.